Shears are typically larger than scissors and used for heavy-duty cutting, and you can insert up to 3 fingers in the handle's fingering. Using more fingers gives you a stronger grasp, which translates into more control and more cutting force. Just don't put your fingers between the blades, because that would be daft. These high-end shears effortlessly slice through produce, snip fresh herbs, and open packaging. Outside the kitchen, they easily cut many materials, including thin aluminium and galvanized steel. The secret to their strength is blades made of stainless steel, which contains a minute amount of carbon. To make them, workers feed a bar of this high-carbon stainless steel into a press. It stamps out blade shapes called blanks. Stainless steel can be heat-treated to make it more durable and corrosion-resistant. But first, a furnace softens the blanks for the forging process that transforms them into blades. Each blank goes into a forging die that has 2 blade-shaped cavities, 1 strike in each, and the blank is a blade. Once it cools, a trimming press cuts off all the excess metal around the perimeter. Heating and forging tend to warp steel, so another press makes the blade perfectly flat and straight again. Trimming the excess metal leaves some rough edges, so the next step is to smooth the surface with a sanding belt. To make the hole for the bolt on which the blades pivot, they drill a round hole partway through. Then pierce a rectangular hole through the rest. You'll see why later on. Now the blades undergo heat treatment. First, a slow heating and rapid cooling to harden them. Then, to make them tough and durable, a reheat and slow cooling. A grinder shapes the round area next to the tang, the term for the metal core of the handle. With a sanding belt, adjacent corners are smoothed out. Here, 2 polishing wheels give the surface a satin finish. Then an etching machine uses electrically activated chemicals to print the company's name into the thumb-operated blade. One final step before the blades are finished. A computer completes the inside edge. Workers now load 6 blades at a time into an injection molding machine. The machine injects molten plastic into the cavities, then rapidly cools the material until it solidifies. Each blade exits the machine with a molded handle firmly encasing the tang. Now for the final assembly. First, a bolt with a rectangular head is put into the pivot hole of the finger-operated blade. The thumb-operated blade is then placed into the press and bolted again into its final position. A self-locking hexagonal nut secures the bolt from underneath. An automated tightener does the initial fastening. Then workers do the final tension adjustment manually. The final step is to grind the excess plastic off the handle stops. This enables the blades to close fully and in perfect alignment. So why choose the rectangular bolt? Watch closely. It allows you, with just one simple twist, to separate the blades for cleaning and then reassemble them. Now that is cutting-edge design.